So today I'm going to present about 16 to 17 minutes of content and then leave some time for questions, hopefully. And the topic today is going to be data mesh and what exactly that is and why is that applicable to the military and in particular the Army. So first, a little bit about me. I'm Anthony Zek. I run the Data and AI Community of Excellence for ECS. We're a large federal systems integrator. I'm also, my night job, as I call it, I'm a Marine reservist. I have a background in Intel, cybersecurity, data engineering, and AI and ML, which will factor into a lot about what I talk today with data mesh. So, data mesh, where did it come from? Well, data mesh in many ways is kind of the natural evolution or culmination of a bunch of trends within data engineering and analytics in particular. But really that whole term and concept came from a 2019 blog article by Zhamak Dehghani called How to Move Beyond a Monolithic Data Lake to Distributed Data Mesh. And really what it was doing was addressing some of the failures of traditional models of data engineering. She subsequently published a book on O'Reilly with your obligatory animal on it, and it's gained a lot of steam lately. So what are the disadvantages of the traditional models that Dehghani was talking about? Really, it all revolves around centralization. Traditional data models rely on a centralized team, and so that the result is you go from this beautiful data lake to a data swamp. And the reason why that is you have slow updating, because again, you're depending on a centralized team. You've got data generation that then gets put into this data lake, and the data lake now lags where the data is coming from by hours to days. You also have these strong dependencies that are dependent on a centralized team to do updates for. So you are wanting an agile data source, but what you wind up with is this massive bloated data lake that is very difficult to be agile with. Data mesh really is an organizational paradigm. So there are some technologies that are typically considered part of a data mesh, but more importantly than that, it's an organizational paradigm. So it moves how you manage data from a centralized system to a distributed system, where you're putting the teams that are responsible for producing data in charge of publishing it as a product. This is a significant change in how you view how you do data. Now, the centralized team sticks around, and their role becomes that of facilitation of the distributed teams, and we'll get a little bit more into how exactly that works. But now you are switching to a model that actually typically mirrors organizations where it's found in better anyway, because it's not typical for organizations to concentrate absolutely all power and operations in one central place. So this also is accompanied by, call it, it's not platform oriented, so you're not oriented on one particular product or data lake to domain orientation. We're changing how you think about data to a domain. And when they talk about domain and data mesh, it doesn't, how the military refers to domains, space, cyber, air, land, sea. They're talking more of like functional areas, like logistics or cybersecurity. So some of these tenets, ownership of data is given to the data producers. So these then mitigate a lot of the issues that were identified in traditional models. You're avoiding bottlenecks that result from dealing with a central team. You're also speeding up your data replication delays, so your data is fresher. And then you're also giving the power to publish this data to teams that actually understand where the data is coming from, so they're able to better shape how it's disseminated. And so this all rolls up into the idea in a data mesh that data is viewed as a product. So you apply a product lifecycle to data. Data products are tagged with a lineage, so where it came from, some service level objectives, how often are you publishing the data, and then it's measured by its success as a product as well. So this helps you keep around relevant information through measuring how useful it is, how many products it contributes to, but you do need to be careful about how you measure that. For example, if your measure of effectiveness is how many products you have, you're just going to get a lot of products that might not necessarily be useful. So that central team that we talked about before, it doesn't go away. The central team's role changes from one where they're doing all the engineering on the data platform to one where they're facilitating the publishing and consumption of data products. And they're doing that through providing infrastructure resources to the teams that are going to produce those data products. There are a couple planes that they talk about within this model, like a supervision plane where you apply central policies that data product developers can leverage. Data product developer experience plane. This is where the central team provides mechanisms to actually produce their data products. So that central team hasn't gone away. Their role has simply changed to a facilitation one. And then finally, and this is an important one for military context, the data infrastructure plane. This is where you change or more accurately, evolve your approach to data infrastructure from one where everything goes into a data lake in a cloud to a more flexible model where maybe you have some cloud resources, maybe you have some traditional operational database resources, and you can actually incorporate legacy data sources into a data mesh. So another principle is federated computational governance. So this federated governance means you have a balanced approach to how you do governance. So some policies are set by a central entity, that central team, but then other ones are owned by the domain. So, for example, security policies. You may have an Army-wide security policy about access to certain data, but then individual domains are free to also set their own additional policies, perhaps on top of or in addition to that central policy set. So a data mesh versus a data fabric, are they in opposition to each other? No. Data fabric is distinguished by having a single management layer. That does not exclude this data mesh approach. Again, a data mesh is more about an organizational concept, an organizational way of operating, where you decentralize control. So you can have what is termed a meshy fabric, and you leverage those data fabric automation technologies, but do it in a way that is still decentralizing your data production and control. So why does this apply to mission command? Well, it should be, if you're familiar with mission command, it should be fairly obvious. And one of the things that data mesh advocates like to quote is Conway's law. Any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. And the Army preaches mission command, which is a decentralized way of operating. ADP 6-0, if you've been in the Army, is the guide to mission command, and it is all about empowering subordinates' decision-making to decentralize their execution that's appropriate to the situation, which reflects very well data mesh's approach to how you do data generation and consumption. Because you're moving, again, from that centralized model to a decentralized model using mission command principles. So this allows your functional areas to be flexible and maneuver in their use of data while still applying those central policies to what really matters to you. So here are some of the benefits. Information in a product is closer to or at the source. This means it's going to be more timely. You're going to have data that is closer to that source of truth, so increased veracity. You understand where it's coming from. One of the principles of how you catalog data is that you have to essentially indicate what the origins of it are, so people who are using it understand it. And then it's managed by the team who actually manages that domain or functional area. So now they're able to better capture the nuances of the data. It also gives you increased flexibility and speed to update. So since you've decentralized how this is managed, now those individual teams can individually update to match evolving requirements far faster than a central team that may not know or care about your individual priorities. This also, we've mentioned it earlier, lets you incorporate legacy data sources and then evaluate how it's going. So, decided that you want to implement a data mesh now. Well, you shouldn't try a big bang approach. You shouldn't try to do it all at once. You should try to, in the words of Admiral Meyer, build a little, test a little, and learn a lot. And the good thing about a data mesh is due to its decentralized nature, it lets you take it a domain or functional area at a time. You can choose a domain where you're going to have a lot of impact by implementing it, and then you can gradually implement it and learn lessons as you do till you have a more fully formed enterprise all on data mesh. So how is it applicable to JADC2? So data mesh as a concept allows you the flexibility to bridge your service and functional area gaps. So this lets services or functional areas design their own requirements while adhering to central schemas that can be the death of interoperability. This isn't a silver bullet. You still have to come to agreement on some standards, but data mesh functionally as a concept allows organizations to retain autonomy while still making them interoperable. And this is really key for enabling AI and ML. And that's actually one of the key benefits that organizations who've adopted data meshes have done. AI and ML is all about having high-quality data for an algorithm. Without that, you're really stuck. And data scientists need discoverable, high-quality data, and the only way you can really do that in a timely fashion is by trying to go as close to the source as you can with as much context as possible. Without that, you're going to have algorithms that don't achieve the objectives that you want for them. So developing an effective algorithm really is dependent on that data engineering that is behind it. And in order to do that, you need to, in a reasonable time frame, you need to have a flexible architecture, and data mesh gives you that. So I want to talk about Elasticsearch here as well. Elasticsearch has a couple of interesting capabilities that let you implement data mesh at scale. In particular, cross-cluster search and replication. So what that allows you to do is keep data locally, but make it globally accessible. So now you can store your data at the edge in a decentralized way, but if you have a common schema that you've agreed upon, you can actually access data at a global scale from one site. Then it also degrades gracefully. So if nodes within this mesh lose communication, you don't lose all of your data. And you've got lightweight communication where you're just pulling the data that you need. So this is really an advantage when you're talking about operating in a DDL environment where you may need global visibility but you don't have the resources to be able to pull that in terms of communication. So ECS has some experience in this. For CDM, which is DHS's vulnerability management program, we have created a standard schema using Elastic's ECS standard. Yes, I know they're the same abbreviation. We push that out to subordinate programs or agencies, within the federal government. And then we're able to centrally query and pull that distributed data into a dashboard, giving us global visibility across the federal government while still letting agencies manage their own data at the source. We also recently won a contract with Army Cyberspace Command to implement on that same principle for Army tactical units. So we're going to be implementing a model, again, with distributed storage where you're keeping that data locally but accessible from a global location. So here are your key takeaways. First, most importantly, data mesh is a distributed model that allows your functional areas to maneuver through data. Second, data meshes are key to successfully adopting AI/ML because they give you that flexibility to evolve data and to get high-quality data to your data scientists. And then third, Elastic is a product that has some unique capabilities when it comes to considering a data mesh product giving global visibility. With that, just about on time, I'll open it up for questions. So when you query that data locally, you return it centrally. And so there's this concept as well where you can create data products from data products. Say you have an aggregated view, right? And that's one of the parts of the data lineage that we're talking about. The data mesh construct, you take the data that is provided locally, and those data products may actually roll up to kind of an aggregated data product. But you try and minimize that, and every transform you do, you try and add value for a very specific reason. Oh yeah, I'll repeat the question. So when you're talking about moving data, if it remains local, if I'm understanding the question, so the data remains at its source unless you need to consume it, and at that point you move data. So if you don't need to move it, it stays there. That's the key thing. The key idea. And again, you only want to have to replicate or move data when it's absolutely necessary, when you need to make a product from it. So the question is, how do I make sure I get back only the data I need? And that's through APIs. So part of a data library or schema definitions, that is part of a data scheme. So you have this globally discoverable library where you have API definitions saying, hey, here's this data source. You submit these parameters to it, and it will return back this subset of data. So that's a very important part of a data mesh implementation, having that globally accessible and discoverable data library. And there are a couple products that do that. Okay, so the question was about correlation of graph theory and data in a data mesh. So you bring up an excellent point, or an excellent question. If you think about data in a data mesh within kind of a graph theory construct, you are keeping data at the edges now. And when you start making connections, you start adding complexity to data, which is what you have right now in most data lake implementations, which is one of the reasons why they're so sluggish, because you have all these different connections and hidden complexity that you have to deal with, because now you have data moving through multiple pipelines, through transforms that you may not necessarily realize are happening on the back end. So when you consume that data product from a central location, you have a bunch of stuff going on behind it that you may not have realized. Data mesh reduces that complexity by lessening the number of transforms that data is going through before you wind up consuming it. And then you have a clear lineage associated with your data library that explains any transformations a product may have gone for. So when you're talking about those aggregated products, you understand that they came from this particular data source at this time, and it went through this pipeline. So now you actually understand, hopefully, some of the complexity that you might have previously been blind to, and that you were assuming without any real knowledge. Other questions? All right, I think that's in the back. Great question. So, if you've invested in data lake, how do you move to data mesh? Well, moving to a data mesh framework does not mean the death of a data lake. You're going to have areas where data lakes are important. You just want to carefully look at what they're doing. Data lakes have their time and place. You need that sometimes. But you want to try and keep information as close to the source as you can to avoid that complexity that we're talking about with the graph theory, to avoid the unnecessary transforms that add delay and then potential complexity that you didn't realize. So you want to keep your data lake, or maybe decentralize your data lake, have a bunch of data ponds, call it. But you don't want to completely throw it out, and you want to take a look at what is in your data lake and think about what portions of that should remain where they are and what portions should be moved to a data mesh. Other questions? So, it's a great question. Reliability and availability of a network. In some ways, a data mesh is going to give you the ability to deal with unreliable network better. I mean, so if you think about a centralized implementation, it's also going to be reliant on reliability of a network, right? So as you move data into a central repository, that's going to be vulnerable to disruptions. You're also going to burden the network quite a bit more over kind of as a baseline. Now, when a network does go out, in a data mesh implementation, you have the potential, you're going to lose that access to that part of the data for a while, for however long that outage lasts. So that is a disadvantage of not replicating data up. And so that's kind of famous engineering answer. It depends answer, right? There's some things that you might want to replicate up because you absolutely need it, whether the network is up or down, and some things you want to leave in place. But if you're thinking about it in terms of functional areas, now that becomes an operational question. What is the data that I absolutely need to have all the time replicated up versus, what is fine if I lose connectivity and then I can regain it at some other point, and then query and gain access to that data. Other questions? Okay. I have a couple more minutes. Nothing else? Well, thank you all. Appreciate the talk. I will be over at the ECS booth, which is far left corner from here. Available to talk about Elastic or any of these other things.